Oh, hi there. My name is Michael Elder, and I'd like to talk to you today about some new capabilities we have integrating Urbancode Deploy with your cloud and virtualization environment. Our goal is to look at how we can leverage cloud to more quickly set up complete environments from your compute, network, and storage resources provided by your cloud of choice and the application components that you've already got managed in Urbancode Deploy. Then we'll look at the problem of cloud portability, being able to leverage perhaps Amazon or SoftLayer as your public cloud and having your own separate internal data center cloud backed by OpenStack or other vendors. The goal here is to enable you to port from one cloud environment to another, regardless of which cloud provider happens to be supporting your infrastructure as a service. So let's get started. Urbancode Deploy with Patterns is a new offering that we've made available to help you manage Urbancode Deploy and how you consume your cloud and virtualization environments. In this first demonstration, we're going to take a look at the role of a IT specialist or IT integrator who now has access to create the complete application stack for their application. Here we have a web-based editor with components that you know already from Urbancode Deploy. These match to the components that are available in your existing applications. And we're going to use those components to describe how we map into your compute, network, and storage resources. Here, each of these resources are backed by an OpenStack cloud. Our diagram editor allows you to navigate and quickly create resources, but we also support a source-based editing view, which is based on the OpenStack Heat Orchestration Template, or HOT format. Here, we're going to provision this template into an environment, creating the virtual compute resources and attaching them to a network. These machines, these virtual machines, will then have an Urbancode Deploy agent installed on them, and that agent will be wired back into Urbancode Deploy. At the same time, we're going to create all of the environment resources required to manage this virtual environment, including the resource tree, the agents, and the component placement rules required from an ongoing management perspective. Here in Urbancode Deploy with Patterns, we can also view the virtual resources for the environment. So if we take a look, we'll see these virtual images, which map into running virtual hosts in your OpenStack-based cloud. We also can see what components are deployed in that environment. And if you have links, such as to the web-based application, you can actually insert those into the template as well. Once the agents come online, within 2 to 3 minutes of starting the operating system, they'll actually call back home and we'll see them appear as online in Urbancode Deploy. Once the agents come online, we will then actually deploy the first version of our component into that environment. Here we can see that one of the machines has already been deployed, and now finally both of them have the correct version of the component on them. At this point, I can use Urbancode Deploy to deploy new versions of those components, or go back into the template and make adjustments and apply those changes to the virtual resources directly. So previously we looked at a designer or an integrator creating the template and deploying the environment. Now let's look at this from the perspective of a consumer, of a developer or tester who's now going to use that existing template from Urbancode Deploy to stand up all of the resources required. This helps you avoid the typical bottlenecks that you would have going in and configuring physical servers or standing up virtual servers and configuring them by hand. Here, we're actually associating it with an existing network. We might have other parameters exposed, like the size of the image, the number of nodes to put in the cluster, or other networks that we wanted to attach it to. We can see this new cloud-managed environment in Urbancode Deploy knows the template or blueprint that it came from, and also has the capability to update the running virtual resources from new versions of the template that are made available over time. Here in Urbancode Deploy with Patterns, we can also see this new virtual environment and the resources associated with it. So things like IP addresses, the size, or the SSH key pair help you then know how to connect into those virtual systems if needed. Again, just as before, we have the entire resource tree created within Urbancode Deploy, as well as component placement rules, etc. And we can deploy new versions of those components just as we would for any existing environments. And here we can again see just that diagram view showing the representation of the agents and their placement on those VMs. So as the system comes up, we're actually installing the Urbancode Deploy agents onto the virtual systems, and that agent then connects back. Here we can see that our desired inventory is to deploy that version of the component, and we've caught it right in the midst of running the installation. Here now, both nodes now have the correct version of the component deployed on them. One of the common challenges that most vendors have today is looking at what clouds to consume. Most vendors have clouds that are either on-premise or they're looking at consuming off-premise clouds. And a significant challenge is which one to bet on. Most customers have chosen a hybrid cloud strategy that allows them to choose multiple public clouds and then also likely have their own internal cloud running in their data centers. This might be because of lines of business being able to consume perhaps AWS or soft layer services more easily, while the internal data centers are designing their own strategies perhaps around OpenStack or VMware or other cloud options. Here we're going to see a demonstration that describes a complete template for your environment, for your cloud environment, that is designed in such a way that the template itself is portable between different kinds of clouds. So this provides a really powerful capability for you to actually go in and design your architecture one time. The resources that are described in this template actually capture everything required to set up a network environment. From the network to the subnet to the router to the gateway, these resources capture important things like what the subnet range would be. And we're based on the OpenStack hot format, which is an open community-driven standard, but we've been able to extend that to add additional value above the community where we can describe these kind of portable properties. We do this by effectively decorating the existing types with our custom types, which still enables the template to work against a vanilla OpenStack, but also now provides this value around portability. So what we're going to do is actually take this template with a configuration file designed for Amazon and for OpenStack. Here, the configuration files capture the specific parameters that are different between these two kinds of clouds. That enables us to keep the template more consistent and more portable, while the configuration binds it to a specific environment. Here, we're going to define this new network in OpenStack using that configuration, so defining pre-selected values for our parameters. We're going to attach that to an existing public network for routing concerns, and then provision it. What's happening is now we're provisioning and creating the network resource, the subnets, the router, the gateway, and creating a virtual machine that will have an IP address assigned from that network. Now, if we look in Amazon in my console, we can see a few existing virtual networks, but we're going to create a new one with that 172.50 subnet range. So here we'll provision the template again, but now choosing Amazon as our target environment. When we select the Amazon configuration, the tool is smart enough to know now you're talking to Amazon and to provide the feedback cues directly from Amazon. So instead of the flavors from our OpenStack cloud, we can see the flavors, the images, and the networks that are coming from the Amazon environment. Now we'll provision this as well. Again, we're generating that deployment call to the heat engine, and now the heat engine, instead of talking to OpenStack, is talking directly to Amazon. We'll quickly see that new virtual network appear with the 172.50 network range. And supporting resources like the subnet, like the routing tables, and the instance have been provisioned in that environment. Similarly, we can go and view the OpenStack network as well. Here in our environments view, we can see the OpenStack pattern that was provisioned with one compute instance assigned from that 172.50 range. So that indicates that our subnet definition was good and that OpenStack was able to configure the network on the appropriate subnet range. And at this point, we actually have provisioned the network twice, allowing us to use the Amazon environment perhaps for development and test activities, and then later on take the same template and promote it into production to replicate that environment for our production managed systems. All right, so with that, I hope you can see how Urbancode Deploy with Patterns can help you extend your cloud and virtualization technology and make that part of your complete DevOps delivery pipeline. What we saw was actually creating the complete application stack, both as a designer, such as an IT specialist or an IT integrator, designing and iterating over the template, and as a consumer, a developer going into Urbancode Deploy and creating a complete environment with just a few button clicks. Then what we saw was how you do network portability, showing how individual applications can be designed to work on both Amazon or SoftLayer, as well as your own internal cloud structures. So the net result gives you much more flexibility in order to speed up your entire delivery process from beginning to end. Thank you for your time.